Okay, until last 2 weeks, we have covered until grid connected PV system. Okay, grid connected PV system, and we did some revisions, and the assignment target is I will release on next week. Okay, next week, week 11. Then the submission, maybe I will allow you to submit until before the maybe end of study week ke. Okay, mungkin sekitar tu around 4 weeks, 4 to 5 weeks. Okay, so now we are going to proceed to the next chapter. Actually, we return back to the chapter 4. Before this, we just bypass the chapter 4, go directly to chapter 5, grid connected, and then we return back to chapter 4 again. Because the chapter 4 for me is not that critical like the grid connected. It is SAPV, standalone PV system, or PV standalone system, whatever. Okay, it's actually the off-grid. Okay, off-grid PV, OGPV also they say. Everything lah, standalone or PV standalone, whatever. Okay, so disclaimer here. Okay, this chapter is not, to be honest, it's not following the SEDA one. I mean the grid connected, we are following the guideline from the SEDA. I mean the book that I follow is basically from the contents itself. Majority of the contents we extract it from the real practice courses for the GCPV under the SEDA training lah. But for the standalone, we are not following the SEDA one, because the SEDA type of the standalone dia panjang pula, So we with the content developer Dr. Shower before, we've discussed and we are going to go with these contents only lah. This contest, maybe you cannot go proceed for the professional designer. But inshallah for only for your household, maybe it's okay. It's okay to be used to design the standalone system, your own standalone system. Okay. Present disclaimer, it's not coming. The contents here that I will teach you after this is not from the SEDA, not from the SEDA one. Okay. Right. So expected outcome, though we don't have any practical practice or the face-to-face practice or lab, something like that. We are going through the theory in most of the cases, but I hope from the understanding from the content from this chapter, at least after you finish this chapter, you have an idea how to start up your own standalone system. Okay? For example, even for 100 watt system, for example, at least you know already lah. Okay, the very basis of the design for the standalone. Before I start, any question? Mula-mula dah start any question dah. Any question? 41 dah ini. Tak ada soalan?
Tak ada.
Tak ada lagi kan? Saja nak tengok korang ni tidur lagi ke apa. Okey kan Khalif? Khalif. Oh, tak dengar.
Okay, sir, okay.
Okay Kita okey dah semua. Okay, start testing dulu. Okay, boleh. Okay, standalone system does not have a connection to the electricity main grid. Okay, or we call it as the off-grid as well. We also call it as the off-grid standalone. Off-grid PV, ataupun dia ada juga ada punya simplified punya abbreviation, OGPV. Okay, kalau grid connected, bahasa roasting machine ni GCPV lah, kita panggil GCPV, Grid Connected PV System. For standalone tu kita panggil off grid, so off grid PV or OGPV. Nampak cara sikit kan. Okay. Standalone system vary in size from watches or calculators. Ni kalau old school dulu awak tengok lah kan, kalkulator lama tu yang korang punya tu, korang punya ke? Abang atau adik-beradik ataupun mak kau punya kan, dia stand macam ni kan. Bukan scientific lah, dia pesan nak dia ada solar kat ni kecil kan. Ni dari sini dulu kita ada lah, tapi tak pakai pun, biasanya dia pakai battery built-in kan. Okay. To remote building or spacecraft lah, so which is the standalone system ni memang boleh guna lah, spacecraft, space system so kan, because in the space, outer space, we don't have any obstacles, we don't have any what we call it cloud, we only have direct sunlight or direct radiation from the sunlight itself. So means that we get the 1367 watt of meter kan, when you are in outer space lah. Itu siapa astronaut lah, tak ada kena pun untuk kita. Tapi that one is only available energy resources is the PV system there lah, is standalone lah. Standalone, that's why standalone very applicable and remotable system. So if the load is to be supplied independently of installation, the generated power needs to be buffered with battery. Ini nanti kita pergi detail sikit lah. Yang ni independently of installation, generated power need to be battery. We need to have the battery if we plan to use it during the night. Because the night we don't have any installation or irradiance. Because the sunlight is not there. Because it's night. It's night, no sunlight. That's why we need the battery to buffer the generated energy through the day, so that we can store it in the battery, then we can use during the night or the early in the morning. That's why people use the battery lah. Okay. So very introduction lah. Okay, this is an example. Termasuk terus keluar bunyi. Okay. So this is an example of structure of the standalone. Okay, the basic structure of the standalone. Basically we have the three types of parts. Because of the PV, then we need PV array. It's a must. Mestilah, jangan tanya lah kenapa ada boleh datang kan. Ini adalah symbol for the solar module. Okay, solar module. Then we have the balance of system. Balance system, sebelum ni kita tak masuk kan inverter semua, tapi tak apalah, kita anggap part ni adalah balance system, whatever. Kita ada charge controller, we have the battery banks. Charge controller ni lah yang sebelum ni kita learn, kita ada PWM, okay. Then we have the MPPT, okay, MPPT charge controller is all here. And then we have the battery bank. So battery bank ni, when you call battery banks, means several batteries are connected in series or parallel. It's a pack, several packs of batteries, set of batteries. So maksudnya ada banyak lah, lebih daripada satu lah. Kalau battery bank ni usually we more than one pieces lah. Of course lah, and we call that as battery banks, bank for the battery. Then this one also we can use the lead acid, okay, SLA ke, seal lead acid or valve regulated lead acid, contohnya BRLA kan, valve regulated lead acid. Waktu sekarang kita pakai lithium iron phosphate ke apa, yang baru pun lah pakai lithium atau pakai lithium lah. So it's all about the battery lah. And then standalone inverter, it's not same with the grid inverter. So ini grid inverter ni dia tak sama dengan grid inverter lah. Tahu lah kan sebab apa. Standalone, like I told you before, you need to know, standalone is based on the battery, and based on the battery and battery size can be 12, 24 or 48 volt input. Okay, based on the battery, mean the battery voltage base. Okay, basically the input of the standalone inverter based on a 12 volt battery. Okay, that's why we have the 12, 24 and 48 inputs of the standalone inverter. And the output one, of course lah, dia ada single phase or three phase lah, depends on the equipment that you buy, the inverter that you buy. If you buy it will only can be used for the single channel, single phase lah. If three phase, then three phase. Okay. Because inverter we need it because we use AC load, and most of the cases we use AC load. Okay, AC load, and this one is the distribution panel, whatever it is. And then for the DC load, we divert it after the charge controller, okay, before the inverter, because the inverter AC, the output of the inverter is AC, but the input one is the DC lah. Then that's why if we can use the DC load, now we have the LED and LED bulb, a lot of, then we have now fan, okay, table fan ke, then maybe we have the DC air conditioner kan, DC cooling system. This pun boleh guna lah. So kita boleh avoid because when the energy is go through the inverter, and of course they have the converter, they have maybe capacitor, resistor and so on. So that one will contribute to the loss of it will be dissipated as the dissipated power kan, as a loss. That's why if we can use directly with the DC load, then it's quite dangerous because direct current. But if you DC load, then we can avoid the inverter. We're not paying with the inverter efficiency because we directly to use the load. So dia tak ada issue loss lagi kat situ lah. So mungkin dia lebih untuk. Tapi but in the reality, of course people need the AC. Even though you have the RV system, you know RV? RV tu yang Google je dekat YouTube tu, RV kan. Orang duk Malaysia pun dah start masuk RV kan, small house. They said they usually use for the camping or the long travel. Okay, long travel. Sometimes emit from the truck, a small truck, van, or sometimes bus. In the US, they bought a bus and they convert it into the small home, from removable home kan. Then basically, as the additional energy, they put the solar panel on top of the roof of the car. That's why they widely used for the camping, for the long travel, long travel. So ni memang popular sangat lah. So as the additional tu, of course they have their own energy storage, but they have the additional, because they need the solar panel to charge the battery full during the movement of the car. That's why we need to sometimes we use TV also, they put in the car, that kind of that. So we still need the AC load lah. We cannot depend 100% on DC load. We don't have the TV base with DC load lah. Even though the battery, the input power for the TV, television is or the laptop is DC actually, but because we are charging from the plug that stick on the wall that use AC, that's why we use the adapter kan. Adapter will finally go DC into the. Of course, they have the transformer something like that. Even laptop pun bateri laptop bukan pakai AC kan, bateri is DC, but the charger itself dia dah convert semua siap lah pada DC lah, output dia berapa, output DC untuk AC. Okay, dengan saya ke? Saya cakap seorang, tak ada respon lah kau ni. Dengar sikit. Dengar. Lembik ni. So ni okey ni. Oh lupa, ni ada problem sound system kan. Afiq okey Afiq.
Clear.
Clear. Anisha okey Anisha. Kau tidur ni, kau tak kejut ni tidur.
Okay sir.
Okey. Macam tu nak. Okay, saya proceed. Okay, however, there's a limitation of sizing the standalone PV system, to be honest. Even for the PV, when they call PV kan, kita memang ada limitation lah. Apa limitation dia? The weather records for the site may not be detailed enough to do an accurate calculation of the module output. Ini memang critical. Okay, critical. Since the weather record are a summary of the past, they can only suggest what may happen in the future when the solar system is operating. It's difficult to predict accurately how much electricity will be used each day. Okay. We have weather, okay, of course we have weather forecast. Recently, the MAT, Malaysia Meteorological Department, apa dia panggil MAT MET tu kan, we are the weather forecaster to, you know, estimate the flood, the typhoon. Maybe we have already the system, we have established the kind of system, and I think getting better the precision. For the precipitation, I mean the rainfall, total rainfall or the wind, the pressure, low pressure, high pressure semua kan, untuk predict weather, banjir apa semua tu. We have the temperature already. Weather forecast pun memang dah ada temperature, betul tak? Kita memang dah ada pun temperature kita tu. Ada temperature kan, lepas tu ada relative humidity, relative humidity and humidity, and then I think they have the rainfall kan, rainfall ataupun precipitation di dalam milimeter tu kan, macam yang hujan lebat itu kan 20 milimeter sejam ataupun 60 milimeter, something like that lah. Itu memang super heavy rain lah. So we have this kind of data from weather forecaster, and then when they compare with the real data source, they don't differ too much. Dia boleh ambil lah data tu kan. But if you realize we still haven't have the mana ni tingginya solar irradiance. Okay, we don't have this kind of data. Of course, the ECMWF, European Weather Forecast Range, apa nama tah, itu dia ada solar irradiance, but there's still not that, I mean the solid accurate enough compared to the temperature and relative humidity lah. Sebab yang it's very difficult to estimate solar irradiance. It includes several parameters combined to become the, for example, it depends on the cloud covers, cloudy kan, cloud covers tu cloud cover, dia mungkin based on the cloud cover, relative humidity, precipitation, apa sajalah, to estimate the solar irradiance tu. Because once we don't know how much solar irradiance exactly, how much what over square meter per hour, for example, every hour we don't have that kind of data. Temperature we have, since you cannot see any forecaster, commercial forecaster, weather forecaster that can give the value that really accurate. That's why it's still difficult for the standard system or the PV system to predict record tu, tahu berapa generate. But we still have the historical data. That's why they said weather record are a summary of the past. Historical we have dah. Historical data tu we have for the solar farm design. That's why they use the, remember peak sun hours, that peak sun hours per year, something like that. So they have the kind, I mean the one-time value, but to predict each hour, that's one very critical, and still PhD studies and several papers also, they are still, professors also, they are still working on it to get the accurate one. That's why a lot of, if you go for solar radiant forecasting modeling, there are a lot of papers that predict the solar radiant, but still there's no solid punya forecaster yang betul-betul accurate. Belum ada lagi lah. That's why PV ni masalah dia tu lah. Because we cannot, even though we can forecast the heavy rain, sometimes it's totally, what we call it, totally, apa panggil, bias or divert from the forecast and forecasted. That's good thing lah. If divert, then we really hope, for example, forecasting for 31 to 31st will be heavy rain and the second wave of the flood will happen, for example. But there's possibility we can take the data as the precaution for us to be prepared, so that we can be more prepared for that. But still we cannot believe 100% kan, because it's about forecast. We still have, we can make doa kan, so that Allah will take out from the radar tu, dah tak ada kan. Sebenarnya tu Allah jadi, memang boleh jadilah, memang boleh berubah pun. Cuma ni kita tak boleh percaya bulat-bulat dalam tu. It's just the forecaster kan. Dia bukanlah pakar ramal, bukan pakar ramal. Maksudnya that's the study of forecast lah. If divert, then sometimes okay lah for us, because for example, okay, after they always monitoring, keep update every 6 hours, 3 hours, so that data will change kan, through time kan. Itulah. But still untuk PV ni payah tadilah, sebab kita tak tahu exactly sun tu berapa dapat. Selagi tak tu, inilah challenging for the PV system. What we have the historical data lah. Okay. Step to design a standalone PV, there will be several steps here. One is the calculation of the load. Okay, load. Ini very basic and very simple for me. You can at least understand at least the sequence of the importance of to design. Before you buy the battery, before you buy the solar panel, how much solar panel tu, first of all you need to know critical one is the load actually. Load. Calculation of the load demand and determine the system voltage. Means before you plan, for example, plan to put standalone PV in your home because we study from, we take what we call it, we study from what will happen before electrical shortage kan, shortage bila banjir naik, so the shortage semua kan. Even they said there's some people also thinking let's go for the standalone, at least we have backup power, and if something happen then we can climb to the roof, then we can charge the phone so that we can call the police and police or fire, what we call pasukan penyelamat bomba kan, boleh datang cepat lah kan, sebab bateri kita tak charge dan sebagainya. So that one for the safety reason tadi memang ada relevan lah menggunakan PV ni. Walaupun hujan, still there's some little energy, at least sometimes hujan dah berhenti kan, tapi tak ada bantuan sampah contohnya. Saya ucap taziah lah siapa yang terlibat, siapa yang affected, saya ucap taziah. Banyakkan bersabar, kita boleh cakap sabar je, kita tak boleh cakap apa kan sebab kita tak experience kan. Tapi mungkin as the student yang family yang affected tu, saya ucap taziah. Kadang tak prepare kan, dia naik tiba-tiba, air banjir pun naik secara tiba-tiba waktu malam tu, kadang kita tak sempat untuk charge bateri semua kan, which is at the end mungkinlah clothes itu membantu kan, baju dan sebagainya, makanan dia membantulah macam mana pun nak survive, tapi at the end phone dia main peranan kan. Bila kita tak ada unlimited sistem yang kita boleh charge so that we can charge the battery kan, kita tak boleh nak push orang untuk call kan, ataupun nak buat emergency call tu tak terputus hubungan kan, orang tak dapat nak contact kita mungkin jimat bateri. So that when you're thinking about the standalone system ni, I think ada relevant lah kat situ. Cumanya the way you place the battery something like that, how much sufficient tu, mungkin at the end tu the way you decide lah load apa yang nak pakai tu, load energy demand tu. If you plan to do more, then you need have the bigger size lah, not only for the PV, the battery itself you need the bigger size. Okay, yang ni yang battery ni lah, battery. Yang ni dua-dua ni lah saya nak cakap lah, yang bagi saya, bukanlah saya ni pandai sangat, bukan. Kalau yang tak cukup bateri kan, sebab ni lah, tak control load. Load ni tidak relevan dengan size bateri yang kita beli. Kita beli 100 Ah, but we expect to use lots of things. Okay, 100 Ah with the 100 Ah size of the battery, then you can charge your phone for several hours. Then for charge kalau for charge, that one is sufficient lah. But pasang kipas lah, pasang TV lah, apa benda, try nak pakai portable aircon lah, so dia jadi tak relevan lah. Bila load tu betul-betul kita tak kira betul-betul. So that's for me is the mistake. Saya walaupun my PhD study is about PV and PhD saya, lepas tu balik sini pun saya study tu memang student saya pun, even saya punya interest pun is about PV, dan saya ajar pun subjek teknologi dah bertahun-tahun, dah bersemester kan. But still like I told before, I still don't have the courage to buy and to install in my home sendiri. Saya boleh pasang sendiri pun. Saya PV tahulah boleh cari mana semua bateri mana yang okey. Kita sama-sama di Google tu kita dapat jumpa. Tahulah sebenarnya kan, tapi still I'm still calculating. Bunyi macam hujan. Okay. I'm still calculating the cost, the budget, the relevancy of buying this. Is it worth if I plan to use this kind of load? Tu yang betul-betul kira. Sampai sekarang tak berani beli lagi. Saya kata beli tak boleh kan. Beli tak boleh. That's why we are looking. We need to make sure lah the load and the battery ni dia kena relevant. Dia jangan merepek. Biasanya kita guna banyak sangat load ni. Bateri ciput tu je. Tapi nak guna macam-macam kan. So that's the reason why insufficient battery, always insufficient lah. And then they have the system voltage. Ni pun ada dia punya guideline system voltage, dia tak boleh suka lah. Okay. And then second step, then survey of solar resource and the selection of PV modules. Maksudnya kat sini kita ada solar resources tu yang tadi tu. Kita tengok data tahunan satu, lepas tu site analysis tu penting. Contohnya solar resource tu termasuk sekali lah dia shading ke, tak ada shading ke apa benda. Semua tu main peranan lah. Kalau pergi tempat, betul dah nak buat kat rumah, bajet ada dah, tapi ada pokok besar sebelah rumah kau contoh kan. We have the very big tree just beside your house, and it is shading your most of your house. For example, house range, dia ada area tu is shaded. Your house is shaded by the certain area of your house is shaded by the trees and the nearby buildings, for example. So that one not relevant for you to use, even though you have the budget, but still you cannot proceed to that because of the solar resources tu is not there. So dia kelakar, dia tak ada kan. Okay. And then the selection of PV modules lah. Selection of PV modules tu after dah tahu the source semua, and then we select the PV modules after we get the load energy demand lah. Berapa kita dapat kan. Okay. So basically the PV resource tu dia capable untuk charge bateri tu. Berapa size bateri kita. Kita estimate berapa maksimum, kita kena tahu lah IMP dia macam mana kan. IMP tu berapa charge maksimum dia dapat, dan berapa kapasiti bateri kita. Kapasiti bateri kita ada certain, dan berapa yang we need to parallel it, for example, that kind of thing lah. Current tu masuk kan per amps kan, per hour for example. For example, you bought the panel with 7 amps, 7 amps, IMP is 7 amps. Then you have the battery of 14 ampere hour battery. So solutionnya mungkin you beli dua panel yang sama, parallelkan dia, then you are expected to get the maximum charging current, maybe 40 amps. So 40 amps can be fully charged your battery. The battery can be fully charged within 1 hour, for example, that kind of things. And then third step, baru sizing selection battery, and then finally selection of inverter, charge controller and other BOS lah. Okay, inverter tu bila kita nak guna AC lah. Tapi originally kan kita dah tahu lah tadi energy demand kita tak guna AC ke DC ke berapa banyak. Itu tahu. Ni contoh lah, contoh-contoh ada chart-chart, tak tahulah panggil flow chart ke apa. Macam biasalah saya cedok pada saya lepas. Load demand apa semua kan. Okay, kita pergi ni. Okay. Calculation of the load energy and determine the system voltage. Okay, so they have two type of load assessment here. Of course lah ada dua lah kan. Contohnya AC load ni nak guna TV, contoh TV. This load ni mungkin bulb LED kan. And mungkin you guna tak tahulah fan ke, yang DC punya, DC fan. So daily requirement for electricity, unit of consumption for the electricity is in the energy. Okay, so energy means what? P appliances is the power of the appliances, confirm lah, this is watts, and H use is the expected daily use of appliance in hours per day, that's why hour. So ini jadi watt hour lah, sebab ni watt darab hour. So watt hour. What is watt hour? Watt hour is energy. Remember it's energy. It's not power. Okay. Our daily conversation we say power, not enough power, not enough power kan. Not enough power, no power kan. Actually not power, actually energy. From the battery tu bukan power tak ada, tapi tak ada energy dalam battery tu. So but the correct term mean what I'm going to say, what I'm trying to say here is the energy lah sebenarnya penggunaan sepatutnya digunakan. Kalau daripada battery tu, battery tak ada power lah. Cakap tu tak ada power kan. Tapi sebenarnya battery tak ada energy, kosong. Energy capacity tu lah adalah AH tadi tu. Okay. Tapi di dalam ampere hour unit. Dia bukan dalam watt hour unit, dalam ampere hour unit. But it's actually the energy capacity, the storage capacity in the battery is defined as the AH, but it's actually the watt actually, the energy lah. energi yang dalam tu. Power tak simpan dalam tu, energi dalam tu tersimpan. Okay. Boleh Boleh Ni malah boleh?
Boleh sir.
Ni malah, okay? Ni malah senyap. Aisyah okay Aisyah?
Okay, sir.
Aisyah respon, baik. Okay. Alright, so ingat dalam watt hour okay, ada AC dan DC. Okay, contoh example. Ini like I told you before, it's not original guideline from the SEDA. Ini yang berdasarkan beberapa source yang after we go through. Actually design of standalone ni kalau refer certain buku tu lain-lain, mazhab dia lain-lain, dia tak sama kan, dia banyak beza. Jadi kita tak follow yang SEDA punya lah. SEDA nampak macam complicated sikit dan panjang, dia macam menyerupai grid connected punya version. Tapi saya tak nak menyusahkan diri saya dan menyusahkan semua, kita go with the simple one lah. Tapi bila you nak design untuk professional, I not recommend lah. Kalau kerja company betul-betul percaya dengan proposal ni, saya tak recommend lah. You kena refer lagi buku lain atau beli yang buku SEDA tu untuk buat dia betul-betul design lah. Tapi kalau masuk company yang biasa-biasa dia pasang CCTV sikit-sikit macam tu, boleh lah kot menggunakan pakai idea ni untuk tarik wire sendiri, untuk letak battery yang mana satu, mungkin boleh digunakan lah. Ataupun kalau tanya saya, I'm suggesting for the pribadi, the private matters lah, for your personal use. Nak pasang dekat belakang rumah saja, nak try lampu luar tu membazir sangat pakai LED tapi pakai AC kan. Rasa nak buat standalone lah, sebab ayah cakap kau belajar elektrik pun tak tahu benda. Cuba kau try sikit buat standalone something ke yang bagi duit sikit. Contoh lah kan, nak nampak kau elektrik kan. Jadi kau pun belilah satu, gantilah lampu luar tu, mungkin terus tarik ataupun tukar lampu yang betul-betul LED betul. Yang macam pasal malam tu memang betul-betul DC punya LED, bukan yang bulb yang jual kat kedai dia dah AC kan tu, dia dah convert. Dia dah ada converter. Tu ambil yang betul-betul DC original tu, DC LED, beli yang mungkin 15 watt ke 18 watt, pasang berapa biji, full power up, energy up from the standalone. Pasang solar modul, panjat sendiri bumbung atau genting tu, ataupun siapa yang ada slab ke, and then you tarik kabel sendiri, beli kabel sendiri. So you mungkin rasa, mungkinlah, saya harapan macam itulah, bukan saya paksa awak buat. At least after you finish this chapter tu dah ada kegairahan nak buat benda tu, at least kan. Dah duduk rumah kan, contoh duduk rumah, dah belajar online kan, rasa macam nak buat something lah, nampak electrical kan. Kau pun adjust dengan ayah kau, beli barang lebih kurang, adjust betul, ada website yang boleh tanya saya lah, boleh PM tepi kalau ada, saya ada satu examination yang boleh beli solar cable contohnya. Tapi dia ada cost sikit lah. Dia taklah semurah AC cable dekat kedai hardware tu. Solar cable dia lain sikit lah sebab dia double insulated kan. So mungkin, tapi ada website lah yang jual contohnya kan. Buat adjust sikit, lepas belajar ni tiba jadi semangat, nak pasang, try pasang. Bateri pun instead of using the heavy lead acid battery, walaupun gel AGM sekalipun, but it's heavy. If you buy the 100Ah, I think 40 kilograms kot. Entah, mungkin 150Ah dia pergi sampai 50 kilo mungkin. Tercabut tangan angkat kan. Dan maybe boleh pakai yang lithium ion phosphate contohnya kan. Tu kita bincang lebih lah. Okay. So tapi asalnya kena tahu berapa biji mentol yang you nak use, berapa banyak you nak guna, berapa jam. So kat sini kita buat satu table yang simple. Contoh, kita nak guna DC. Sebab tadilah tepi-tepi kan. Lepas tu kau kemaruk juga. Nak juga TV, nak juga petang-petang tengok TV juga, tak kira. Laptop, tak apalah, ni boleh ganti laptop lah, tapi tak apa. Nak pakai desktop juga sebab nak main game. Nak jimat elektrik, pakai PV kan. Okay, contoh. So DC, let's say kita ada 4 bulbs and each bulb cost you 25 watts. And then 4 quantity. So you multiply, you get total power kan. Ini total power, but the real use is not exactly 25 watt lah. It depends on the condition. But LED, I believe, maybe 30% from the rated one. They use only 30% from the rated one, maybe. Itu kena try sendiri lah dan measure sendiri. Total 100, then you expect to use 3 hours only. Contoh, you start to use it from 7 to 11 PM. So waktu malam kan, 10 dah tidur, tak lampu. Okay. Guna 3 hours for 4 bulbs keliling rumah. Then sorry. Okay, means 4 bulbs, each bulb 25 watt, ni tinggi kat lah sebenarnya. Then you use for 3 hours, 7 to 10 PM. Okay, then you multiply it, you're going to get the watt hour. So you're going to get 300 watt hour maximum for the DC, your 4 DC bulbs. Ini expected dia sebab kita tengok rated. Rated tu tidak menipu. Macam mana pun dia takkan lebih daripada tu. Kalau you plan to use the fan lain ke 15-18 watt, you darab macam tu je lah. Okay? Tapi yang watt yang dalam tu memang tak tipu. Tu betul. Tu paling maksimum boleh dapat. Dia takkan lebih daripada tu lah. Kecuali leakage ataupun rosak. Okay. And then we go for the AC one. So kita tak boleh sekalikan DC dan AC tu. Sebab tadi ingat kan, AC is AC. Dia kena lalu inverter. Lalu inverter kan. But DC before the inverter. So we are not considering the inverter that time. But for the AC tu you can separate sebab kita akan ada inverter. Ada calculation related ni dekat situ. And then tadi ni contoh TV ada desktop sebiji. Yang ni pun saya rasa, yang ni pun sini agak sensitif. Desktop saya rasa bukan 100 watt ni. Kalau dia punya power supply tu pun saya rasa 500 watt kan. Ikutlah macam mana you kira. TV ni adalah 80 lebih tu adalah TV yang besar, 540 pun ada saya lepas. Less than 100 watts. And then total watt sama sebab kita satu je. And then you darab type of use. Contoh TV nak kena guna juga dari pukul 8 sampai pukul 10 sebab nak tengok Doraemon. Contoh lah tengok Doraemon kan. Sekarang kan digital tuner kan. Area dah beli dah. Tapi apa tak bagi kan. Ayah tak bagi guna TV tu. Buzzer elektrik. Kau pun beli sendirilah. Pasang guna apa-apa. Jadi tak kena bayar elektrik kan. Kau pun beli. Nak guna juga lepas gua tengok Doraemon. Doraemon dengan Ultraman kan. Okay, tengok 2 hours. Then desktop nak main juga Minecraft. Contoh Minecraft kan. Guna untuk sejam kan. So total up still 300 watt hour, but this one is the AC part lah. And then you plan for example days of autonomy. Contoh kau nak konsisten selama 2 hari contohnya. Tapi ini tak ada pun tak apalah. Ini tak ada pun tak apalah. Boleh singkirkan tak apalah. Okay, tapi ini contohnya ini adalah load yang you akan guna lah. Load yang you akan guna, you plan to use. Remember, when you try to add up, kena kira balik cukup tak bateri yang kita dah design kan. Sebab biasanya itulah, bila kita tambah load, kita akan tambah bateri balik lah. Tapi ni kiranya kau betul-betul you design, so memang exactly for this purpose only lah. But if you want to change from AC to DC tu depends on you lah. Tapi here 300 watt DC, 300 watt hour DC and 300 watt hour AC. Total of load that you are going to use here. But okay. For the real calculation of the load energy and determine the system voltage. Tadi we separate it. Okay, we separate it DC and AC. Okay, betul DC and AC atas kan. Separate dua. Lepas tu kita nak relatekan dua-dua tu, nak campur dua-dua sebab kita nak sekali at the end we are going to use only one battery bank. So all the DC and AC must be together, must to become together and then will be pulled from the same battery banks kan. So even though ada AC dan DC tu still lagi satu bateri. That's why kita tak boleh separate lah. Kita dah sekali tu kena total up semualah. Berapa total up ni kan. Okay, kat sini calculation adalah energy and determine system voltage. Kita ada main system voltage. Macam saya cakap, system voltage ini berkait dengan bateri. Ini yang sistem voltage sebenarnya adalah 12 volt, 24 volt, 48 volt. Okay, ini sistem voltage. Okay, but other than the DC and AC tadi tu, we need to estimate system losses. Okay, ada dua yang kita kena consider. First of all is general system efficiency. Second one is the inverter efficiency if we plan to use the AC. Ni when AC load comes, then we need to consider this. Okay, general system efficiency. Ni yang cakap tadi tu. Saya tak refer daripada SEDA and a lot of books you read, a lot of methods, they use different methods. Yang ni lah kita discuss dah sekali, and several books also we refer. The efficiency of cables, battery and the charge controller, this can be taken to be 80%, meaning 20% of the energy is lost. Yang ni memang totally saya langsam kan. Maksudnya general system efficiency kita tak perincikan. Kalau if you plan to do the very detailed study, dia kena kira battery efficiency, dia kena main dengan DOD tu berapa, lepas tu kena tengok pula data sheet battery tu secara detail. Kalau yang jual kat kedai dia tak detail sangat, beli kat Shopee atau Lazada, a very straightforward berapa AH, DOD pun sometimes they don't write. They don't mention that kind of things. So that's why maybe difficult lah. You kena cari modul, cari bateri yang betul-betul ada. It's very difficult. And then efficiency of cable, something like that, everything kan. So macam banyak lah charge controller berapa, tak tulis pun berapa charge controller efficiency. Kita tak tahu, we don't know. We may know inverter efficiency, but we don't know the charge controller efficiency. Ada loss tak? They still have loss there. Tak tahuan. Jadi that's why ni yang jenis efficiency ni memang langsam punya value. Let's say kita tak 80%, bimbang 70, 65, itu memang totally on the question. I purposely put everything in the question, then 60, 70, 80, something like that 80% maybe okay. Okay, we can consider maybe 80% is okay. Okay, for example, 75 to 80%, maybe you can choose that value. Maybe it's okay for this kind of design, but actually nanti you could, kalau if you want to verify it, you install, follow all the guideline, the SOP, the SPD and the breakers, everything you put there. And cable pun you use untuk battery cable mungkin 6 ke 10, forgot. Then untuk yang modul tu berapa you gunakan. And then apa load you pakai dulu, you try, you ambil data, you collect data dulu, you tengok macam mana. Itu you baru boleh verify is it correct or not. Punya ni assumption ni kan. If you want to verify it. And then the inverter efficiency tu memang you kan boleh dapat memang you boleh tengok pun. So a good inverter, one designed for use in standalone building system, for example, will be about 85% efficient under average loads. Still, this value also debatable debatable. Like I told you, if you looking for the inverter, please looking for the pure sine wave. Remember, the wording of pure sine wave for the inverter, if you try to search in the online Shopee, Lazada, AliExpress, Alibaba, semua ni, make sure the pure sine wave there, the word there. If they don't write anything, trust me, the efficiency is extremely worse. But at least we have the pure sine wave, then maybe better lah. The good one, if you try to find the inverter that have their own datasheet, proper or professional datasheet, their one's better lah. Usually kalau buy from the internet kan, macam Shopee apa semua Lazada, banyak kali sebut Shopee Lazada kan. Shopee Lazada tu tak tulis kadang-kadang, datasheet memang tak ada. Dia tulis kat description. Macam saya cakap, you also know kan, kalau dah benda, if you read directly from the description, they can copy and paste from somewhere and put there. That's why kalau ada brand tu, you boleh verify kan, you boleh cari yang online ke. So depends total on you. Kadang-kadang orang try and error kan, beli try kan. Tu beli lain pula tak jadi. Beli lain, try measure sendiri. Baru puas hati kan. Tapi modal lah. Okay. That kind of things. Okay. Dua ni kita langsam jenis system efficiency tu. Okay. Okay. Saya sempat ni juga. Saya di meeting sebenarnya. Dia dah running dah pun. Okay. Calculation of the load energy and determine the system voltage. Okay ke? Ya. Okay ke ni? Aku cakap seorang. Siti Nuraini. Boleh ke? Siti Nuraini.
Okay, sir.
Okay. Tu Atikah ni. Si Atikah jawab tak nak orang lain. Safi Hanani. Ivan.
Okay, sir.
Okay Najihah.
Okay, sir.
Okay. Nafis.
Okay, sir.
Zulfikri.
Okay, sir.
Lim Sin Ying.
Okay, sir.
Sampai habis baru. Okay. Kita pergi Okay. Barulah shock sikit. Walaupun tak buka kamera. Aku rasa ke depan ni aku nak suruh korang buka kamera kan. Baru tahu kan. Macam mana kan. Lupa kan. Okay. Calculation of the load energy and determine system voltage. So load energy. Okay. Here, we include both. Remember the 300 watt hours that we calculate for the DC and AC? We are going to include it here. This one for the DC and this one for the AC. Okay. Sebenarnya ni is the load energy DC load and this one is coming from your AC load tadi tu. Kebetulan tadi 300 kan watt hour kan. Okay. And sis. Oh ini macam optional nama dia kan. Tak tahu ni, saya tak tahu nak sebut apa benda, saya tak tahu. Bukan N ni. Okay. General system efficiency ni memang totally ikut soalan lah, depends on the question ataupun 80% ke 70% ke 75% ke. In case lah I forgot to put in the question, first of all you can ask me you purposely forgot or not. Tapi saya cakap there's nothing wrong with the question, so you can take from the notes originally 80% number. Even though for those who put 70% or so, no problem for me, but justify the answer. 80% is the from the notes, but due to my worriness, so I took some margin 10%, so I put 70% for the general system C, so that by taking the what you call that, advanced extra margin tu lebih safer lah. Okay. And then inverter efficiency. Okay. This kind of inverter efficiency you cannot use like the grid connected. You remember what? Grid connected, most of the cases very proper and very brand, trustable and very accurate the efficiency, because they had a proper data sheet. Huawei brand, Fronius, IBC Solar, whatever. They are proudly, they're really proud to write the maximum, remember what? Maximum efficiency yang tulis kan kat dalam tu. So tulis 95%, 97, 98. But for the solar standalone this inverter or standalone inverter ni, I'm not sure. Maybe most of the cases they don't go until 90% unless they are clearly mentioned in their data sheet. They are written 90% or 97%, 95% be full of confidence, then you take the value, is okay. But most cases, if the Shopee I told you from the internet you buy just without the 80%, 70%, 60% maybe. 75%, 85% consider good lah. Consider good. But I think 50%, 45% for those inverters that don't have any the wording pure sun wave is worse. It's worse. For example, solar car inverter. That one I think I'm afraid 20%, 30%. Yes. Boleh So this is where the value. That's why simple lah. Memang calculation tu ni memang kita langsam baiknya. We don't go serious like the SEDA one. We just play with it only for the personal use only. Not for very professional proposal. Okay. Then is the efficiency the one lah. Over inverter. Bukan. Inverter sini. Silap. Inverter sini. Inverter only comply with the AC lah. If the AC is not there, so tak ada ni. Kalau no AC. If no AC, load, so you delete lah tu, tak perlu. Ni yang general system itu pukul rata all the losses coming from the cable, charge controllers, battery cable, for example, we consume, let's say we assume 85%. So this is it. So this is we call that as the revised energy required daily, but actually it's the energy demand lah, total energy demand, solid, yang betul-betul ni. Okay, bukan yang original tadi tu. Ini maksudnya ini yang total after consider the inverter, all the efficiency, all the losses that may come from the system. So this is the value. Okay, ini yang equation, kiranya equation pertama lah ni. Okay, as example, okay, like we discussed before in the first page. Kita habis lagi sikit lagi, alamak saya ingat boleh habis banyak ni, banyak pula cakap. Habis lagi dalam 10 minit meeting pula. Okay. DC load we have 300 watt hours Okay. And then we have another 300 watt hours from the first slide I just showed just now. AC also we have the 300 watt hours. And then assume, for example, we have the inverter with the inverter efficiency clearly written 90%. Okay. From data sheet. Okay. Proper lah. Data sheet proper. Proper data sheet, jadi data sheet proper, whatever. Okay. Then we have that 90%. Okay. Logicnya, the logic is mean after output of the inverter target must 300 watt hour. Remember, because we need the 300 watt hours of the AC load capacity. The capacity for the AC load, we need 300 watt hours. Means that's your outcome, that's your output, that is your needs. Mean before that, it totally depends on your inverter efficiency. Okay, inverter efficiency. That's why input from the standalone inverter tu, kat bagi input ni, and sepatutnya will be divided into 90% lah. Dia sepatut memang kena lagi besar lah daripada berapa daripada output yang kita nak. We need that 300 watt hour. So this is the mistake that I told you. If we don't consider the inverter efficiency, sebab kita nak 300 watt hour ni, kita pun tibailah pakailah anggap inverter tu apa yang masuk sama keluar. Tak, dia actually nak. The calculation is not like that. We cannot get 300 watt hour before the inverter, the same we get the 300 watt hour. That's the different, I mean the mistake thinking. That's the wrong thinking of that. It's actually, you need to divide with the efficiency of the inverter that you use. Okay? So that's the logic of that previous calculation. Then, okay, at this point, we are going to have 300 watt hour, 0.9, and we have another 300 watt hour of DC. Okay? DC is 300 watt hour and the AC is 300 over 90%. And then here comes the efficiency of the cable, charge controller, battery cable, all of that, all the things, all the stuff, the whatever. So let's say that I told you, we put here, for example, 85%. Or in the question, I just put 80% ke 75%, depends lah. Okay, depends lah. Even though maybe you use kabel bateri berapa lah, siapa tahu? 6 ke 10 lah, ingat lah. Biasa kabel bateri ni, daripada bateri ke bateri bank ni, orang guna kabel dia tebal sikit. Okay, ni kabel ni biasanya original power solar module. Basically we use the original one is the 4mm square. 4mm square. But the cable battery cable, siapa yang pernah main dengan ni mungkin tahu 6 or 10 lah. It's not 4. Okay. By considering we use the 10 and charge controller also MPPT, you buy the MPPT one and you buy okay lah, brand pun nampak macam boleh percaya je. But still we consider this kind of 85% as the safer side. Kita still 50% tu from somewhere connection dia, bateri dia ke apa ke, casing dia tu ke, heatsink dekat charge controller tu tak cukup ke, by considering that lah. So at the end, the original that we need to have for our the original energy that our modules ni, our PV array need to produce is actually 300 plus 300 watt hour over 0.9 and over 0.85. So dekat sini, after kita kira, we get 745 watt hour per day lah. If we assume for day, kita tadi dah setuju untuk satu hari punya load kan. So actually, we need this. We cannot 600 watt hour is not enough. Most mistake that has been done by the noobs and the rookies or the person who doesn't have nothing, doesn't know anything, but have money, budget, try to start to show off to others that have capable to put the solar system in our house. So that's why they put they connect everything, buy this one, this two, and sambung. Yay, siap. Dah sekali tak cukup. Bateri tendang je. Habis, padam dah lampu. Dia banyak air je. Air dia banyak sangat. Why? Because thinking 600 watt hour. Jadi, 600 watt hour lah, settle lah. 600 watt hour means what? Buy only 4 solar modules. 150 for example if you buy plan lah, for example 150 ni saya cakap per day saya ada work per day. Let's say lah dia nak per hour per hour dia critical sikit. Okay, dia beli 150 ni 4 dapat 600 watt hour, dapat dalam sejam tu produce 100 watt hour. Tapi sebenarnya after considering the loss dia sebenarnya pakai 745 watt hour. in 1 hour, for example. So that's why maybe after using 40 minutes tu dah padam dah, tak hidup dah lampu, dah padam dah semua kan. Sebab dia kata apa rosak ni, bateri tak ada brand lah, tipu ni lah. Contohlah, that kind of things lah. Dia start the shutdown. Sebab apa? Yang ni pun dah salah. Ini saya rasa yang mistake, yang common mistake that people who doesn't know anything tu, basis ni dia akan buat macam ni terus. Dia pasang, sambung jadi, jalan. Dia kira 100 watt load tu 100 watt settle. Yang dapat guna separuh tu bagus lah kan, considering bagus separuh dan sebagainya. Tapi ini secara idea lah. Ini saya tak masuk bateri lagi kan. Bateri punya calculation lain pula. Berapa kapasiti bateri tu. Sekarang kita cerita load tadi, nak cover load tadi tu. Yang masuk pun dah tak cukup, macam mana nak charge bateri lagi kan? Lagi jam lah. Macam tu. This is the very basic lah. So what important here, the most important here is set your mind. If you use the maybe ni berapa ni beza dia dalam 145 watt hour difference, 25% extra, maybe you need to consider you can only use 75% around saya ni kira ni agak-agak ni, you need 125% from your load. Macam tu saya fikir tu. Kalau you kira 1000 watt hour, means that you need to have the PV module that can produce, that can supply energy or supply energy with capacity 1.25 kilowatt hours. Macam tu. Bukannya 100, bukan 1 kilowatt hour, tapi sebenarnya 1.25 kilowatt hour. 25% extra lah. Senang cerita. Kalau dari sini lah, mean we need 25% extra energy so that we can get the energy for our load that we already set in our system, in our house. Macam tu. Begitu hendaknya. Next apa? Okay, inilah saya. Janji. Okay. Boleh? Boleh? Okay? Is it okay? Okay ke semua? Fakhrul. Okay, Fakhrul. Tak ada. Lui Hon Mun, is it okay? Lui Hon Mun. Tak ada respon. Lo Yen Hang.
Yes, okay, sir.
Okay. Fast respond. Ho Chia Hui.
Okay, sir.
Okay, right. Okay. Then after that, here come the system voltage. Okay, system voltage ini, okay, ini I didn't cheat, I didn't lie. It's actually coming from the SEDA. Ini memang SEDA punya guideline lah. Ni bukan tipu-tipu lah. Ni bukan kita orang fikir-fikir sendiri buat. Ya, ini system voltage ni recommended ini adalah based on the SEDA punya. Saya dah refer. Jumpalah dalam buku tu. So, system voltage is the nominal voltage at which the batteries, charge regulator and solar array operate. Also, system prices often operate at the system voltage. The system voltage tu ada 12. Ini sebenarnya ada 96. 96 tu ada. Okay. Tapi yang most cases tu 12, 24, 48. 96 tu extreme punya level extreme. Dia punya load lagi gaban besar. Ni memang mega size lah. And then it's recommended to use, okay, ini remember it required daily less than 1 kilowatt hour. The first one that we calculate just now, less than 1 kilowatt hour is enough, sufficient to use only 12 volt battery. Means only single 12 volt for the system voltage. Okay. But it's not about how many days you want to use. If you want to use for a week, that's a different thing. Means the parallel one, itu kena based on the berapa hari kita nak guna tadi lah, berapa load banyak. Capacity tadi tu bergantung kepada berapa hari kita nak tahan dan sebagainya lah. Ataupun nak tambah lagi berapa jam. Contohnya kan. Yang itu parallel tu kita buat untuk dapatkan capacity yang lebih. Capacity lebih means that dia akan lebih banyak boleh simpan energy. And then but the system voltage is remain the same 12 volt because kita punya 745. Okay, alright. And then if your load between 1.0001 to 4 kilowatt hour, then recommended one is 24 volts. Okay, if you see in the website ataupun macam cakap lah, there's several Facebook group kan, Facebook page, FB page that telling install everything there. If you see that kind of thing, for me, I would like to say directly comment, saya suka komen dalam tu kalau tulis dia guna 12 volt je tapi dia guna load 30 kilowatt, tu memang tak berilmu dah. Sepatutnya kalau yang betul-betul ikut guideline lah, yang betul ada ilmu sikit, between 1 to 4 you need to use 24. More than 4 kilowatt hours recommended one is 48 volt DC. 48 volt DC ni apa maksud dia? Sambung bateri 12 volt tu secara series. Okay, sebab 1 12 kan? 12, then you get 48 volt. The capacity is different things. Tu nanti kita cerita lain. Sekarang ni saya cerita dulu sistem voltage yang relevan. Yang relevan untuk sistem tu. Recommended one, remember, less than 1 kilowatt hour, several hundreds watt hours is enough to use 12 volts. Bigger than 4 kilowatt hour, then you need to use 48 volt. If you see in anywhere, any person you see they design 4.2 kilowatt hour, for example, they use the 24, they will face struggle. They will struggle. There's one time where the battery is going to that earlier than they expected. Sebab tadi tak cukup. Dia ada capacity dia. Tu agak detail. The voltage drop depends on the load tu. Study yang sangat detail. Benda lain tu sampai PhD punya level kan. Dia nak tengok kenapa 48 tu relevant tu. Watt yang kita guna, load yang kita guna tu sebenarnya dia ada drop lah. Voltage drop tu. Bergantung lah pada berapa load yang kita pakai. Lagi amps tinggi kita pakai, drop tu lagi tinggi. So kalau battery voltage tu 12 volt, dia akan cepat dia cut off. Tapi kalau battery voltage kita 48 volt, dia dalam lagi kan, dia jauh lagi kan. Itu maksud dia. Tak apalah kau tak faham pun. Just nak dapat idea lah. So if you see people use 4.5 kilowatt hour system. Sebenarnya dia punya load semua 4.5 kilowatt hour tapi dia guna 24 volt battery. Maka tegurlah mereka. Please say to them, Pakcik, this is wrong. This is wrong. You need to have another 12 volt battery, 2 pieces of 12 volt battery so that your system 48 volt. Then maybe you are not going to face anymore the sudden shutdown of your system lah. That's why kena guna 48 volt for example. Okay, itu saja. Yang ini tak apalah, ni minggu depan je lah malah nak sentuh. Okay. Any question? Any question? Okay, mesti tak ada. Kita panggil nama. Anisha ada soalan? Anisha.
Kakak ni tak ada, doktor.
Cakap tak ada lagi siapa lagi? Dia nampak nama tadi. Khairul Nisa.
Ya, doktor.
Any question?
No.
No. Okay. Ji Shan Yong. Betul ke sebut? Tak tahu. Ji Shan Yong. Any question? No? Oh, tak respon. Tidur lah. Atikah. Tuan Nur Atikah. Ada soalan?
Tak ada, sir.
Ada. Atikah Nurdin. Ada soalan?
Tak ada, sir.
Tak ada Korang macam penat semua aku dengar suara. Okay, kalau tak ada, kita habis kat sini Okay. Thank you all and jaga dirilah elok-elok Kita harap, kita doa lah supaya gelombang kedua banjir tu tak ada lagi. Okay, supaya fokus tu dia lari lah. Okay, terima kasih.